Two very different creatures share the same gene. A family of butterflies lives in the American tropics. Over hundreds of years, they have been evolving at amazing speeds. The family includes many different kinds of butterflies. They all share a taste for poisonous plants. That makes them poisonous to eat. The butterflies have evolved to copy one another's wing patterns. The patterns send a clear message to predators. Things that look like us taste bad. The patterns signal, stay away. More recently, another winged insect changed its form. It also did so to avoid being eaten. This insect is the peppered moth. It lives in England. In the early 1800s, peppered moths had white speckles. Then England started building factories. The factories burned lots of coal, releasing black soot into the air. Soon the country's white birch trees were covered in soot. In response, the peppered moth evolved. Their wings turned black. Darker wings helped the moths blend in. They could better hide from predators on the soot-covered trees. The butterfly and moth stories may sound familiar. They are both famous examples of evolution. Useful traits are passed on. In the 1800s, Henry Walter Bates went to Brazil. He found the pattern Heliconius butterflies there. Bates was excited by the discovery. He thought the butterflies were proof of natural selection. Natural selection is an idea about the way living things have developed over time. It says that some creatures have useful traits. These traits help these creatures survive. The longer they survive, the more they can reproduce. When they reproduce, they pass their useful traits on to their offspring. This idea is also known as survival of the fittest. Traits are passed down through genes. Genes control how living things grow. The set of genes in an organism is known as its genome. Scientists wanted to know how butterflies and moths changed their form so quickly. They thought the changes came from a single gene. Scientists narrow in on the cortex gene. Illik Sakari is a scientist. He studied the peppered moth. He searched its genome. Sakari was looking for genes involved in coloring and appearance. Meanwhile, scientist Chris Jiggins studied the Heliconius butterfly. He was also looking for genes related to color and appearance. He searched the butterfly genome for them. None of the genes turned out to be right, though. Eventually, both scientists narrowed in on a different gene. It is known as cortex. The scientists were surprised. The butterflies and moths are very different creatures. However, they share the same cortex gene. It has remained basically the same. It has not changed, even as the organisms evolved. The cortex gene is important, Sakari said. He believes it shows that there are hot spots for adaptation. These places on the genome are very good at mutating. For example, they can help creatures quickly evolve to have a new look. This may increase their chances of survival after the environment changes. Evidence of natural selection. Scientists still have much to learn about the gene. They do not know how it creates changes in pattern and color. For now, Sakari hopes his study will help people appreciate the power of natural selection. It is not a made-up story, he said. There's more and more layers of evidence.